Solar radiation management are typically aimed at changing the Earth's albedo or blocking incoming solar radiation. A popular idea is to increase sulfates in the atmosphere, which increase cloud cover, thereby increasing the Earth's albedo and reflecting more incoming energy. This is a bit like what happens with a volcanic eruption. There are three problems with this strategy. One, it involves continuous additions of sulfates. There are real possibilities of altering the distribution of water on Earth. And three, it could lead to other environmental problems. The positive are that it's relatively feasible and inexpensive. The second group of SRMs proposes putting large shades up in space to block incoming radiation. This is safer, but extremely costly. Negative emission technologies include a variety of measures that would remove carbon from the atmosphere. These include several possibilities listed here. This slide shows why nets are even being considered. The gray line shows the current emissions trajectory. The blue line shows the emission pathway we need to take to avoid dangerous anthropogenic interference of 2 degrees C. The green line, a more likely pathway. If we follow the green line, we will not be able to avoid 2 degrees C. So, in order to get to that point of avoiding 2 degrees C, we need to remove carbon dioxide from the atmosphere. What seems to be a simple solution is afforestation and reforestation. If we planted 1 trillion trees, we would need 900 million hectares of land. If we could do this, we would be able to remove 205 gigatons of carbon from the atmosphere. This is sizable. Is it possible? Maybe. But there's still lots of debate in the scientific community. These are some of the arguments scientists have made against the effectiveness of afforestation and reforestation plans. However, it doesn't really hurt to plant more trees. Another type of net are bioenergy carbon capture and storage, or BECCSs. These increase biomass, such as terrestrial vegetation or algae and aquatic systems, then burn the biomass and store the carbon released through burning underground. BECCSs have only been done on a small scale and are very expensive. To move this technology to a large scale poses many other environmental challenges. Direct air capture involves removing carbon from the atmosphere using chemical methods. Here, removed carbon is stored in the pore spaces of sedimentary rock or building materials, or used to weather rocks. Review the next 2 slides for more information on direct air capture.